Okay, let's start with the fourth one over here in irrational. So part 2, let's start with it. Here you have the fourth one where root 5. So we must prove that root 5 is an irrational number. So as we have proved in the previous questions, where in the previous questions they have given something like kind of these questions where 3 plus prove that 3 plus root 2 is an irrational number, or 3 plus root 5 is an irrational number, or 2 plus root 5 is an irrational number. They have given some kind of questions like this, but in this one they have given root 5. So now we must prove that root 5 is an irrational number. Now to prove a number, to prove something an irrational number, then what you do firstly, you consider firstly that we must assume, right? Okay, we must assume, or you assume that the given number as a rational number. If we cannot prove that the given number as a rational number, then it definitely would become what? An irrational number. If we cannot prove the given number as a rational number, then it definitely would become an irrational number. So then what you do? Firstly, you assume the given number as a rational number, then it would become, if we cannot prove, we know we don't prove, we cannot prove, so then it becomes what? It becomes an irrational number. Clear? So now let's start with it. Firstly, here you have the solution. So here you have root 5. Let what? Let root 5 is a rational number. So consider this, where root 5 is a rational number. Where rational number is always in the form of, we are learning since 8th class, where rational number is always in the form of p by q, where q is not equal to 0. P and q are integers, right? We know this. Where rational number is always in the form of p by q form. Q is not equal to 0. P and q are integers. Okay, p and q are integers, where q is not equal to 0. Now what you do instead of p by q? Okay, to solve this given question, instead of p by q, guys, I would like to take a by b. Okay, a b instead of p by q, I would like to take a b values. Okay, so now what you do, you go for root 5, where root 5 equal to, as I have said, where root 5 is a rational number, then root 5 equal to what? A by b. This becomes a by b, right? Where b is not equal to 0, a and b are integers. Now here the next step to be done is you square on both sides. Make squaring on both sides. SOBS. Okay, squaring on both sides. Squaring on both sides. But writing while writing in exam, you write the full form. Don't write SOBS. Okay, you won't get marks for it. So now here you are squaring on both sides. Now let's square on both sides, where root 5 whole square equal to a by b whole square. A square by b square, right? A by b whole square, a square by b square. Now what happens, where square root cancel here on this side, on the LHS side, where square root gets cancelled. Now what you do from RHS, okay, let it be LHS side, you cancel square and root. So here you have b square. Now transpose this b square to the other side. Transpose this b square to the other side. So here you have b square. Now when we transpose this b square to the other side, this becomes what? Multiplied. Then what happens, where a square equal to 5b square. Clear? A square equal to 5b square, because I have transposed over here where 5b square, or okay, let it be. So a square equal to 5b square. Now what happens, guys, here coming back to here, where a and b in this question I was writing firstly, where a and b are co-primes. Remember, a and b are co-primes. Co-prime numbers, right? We know we have learned in our earlier classes, where co-prime numbers are the numbers they will only have one factor. Okay, they will only have one as the common factor. Means something like, okay, they will only having one as the common factor. For any numbers where one is the common factor and the number itself is the factor, right? So here where a and b, they only have one as a common factor. They won't have more than one numbers. Okay, so here you have 18. Let's go for 18, where 18 equal to 2 9s are 18, right? 2 times 9 equal to 18. So 2 9s are 18. Where 18 factors, if you ask us what are the factors for 18, then what you do? What would I say? I say 1 will be the common factor for every number. 1, 2, 9 and 18. So this might be the common factors if you have factors. 3 6 are 18, 3 6. So all will be the common factors. Okay. So these will be the factors for the 18. But here they have given co-primes. Co-primes means you will be having only 1 as the common factor. Clear? Now coming back to here, where a square equal to 5b square, 5 into b square. So as I have said, 18 equal to 2 into 9. Okay, 2 is a factor, 9 is a factor. But here a square equal to 5 into b square. Right? Are you getting it? A square equal to 5 into b square. 5 will be a factor, b square will also be a factor. Alright, so here where 2 can divide 18 over here, 2 can divide 18, here 5 can divide a square. Alright, so therefore I can say 5 divides a square. 5 divides a square. If 5 divides a square, then 5 also divides a, right? 5 divides a. Clear? Let us consider this statement. Okay, let's consider this statement. Let's keep this statement aside. Now you go for the next one here. Are you getting it? As here, where 5a square equal to 5 into b square. 5 into b square. Assume into multiplication over here. Where 5 divides here, where 18, 2 divides 18. Then 5 divides a square, right? So that's what I have said, what? 5 divides a square. 5 divides a square. If 5 divides a square, then 5 divides a also. Okay? 5 divides a also. Now here, now let's consider where a equal to 5c. A equal to 5c. Okay, here we have taken b as a variable. Now you take what? C. Is the board clear? Very good. So let a equal to 5c. Then if a equal to 5c, what you do? Again go with this process, squaring on both sides. SOBS, squaring on both sides, guys. Okay, squaring on both sides. Okay, now what happens here? Squaring on both sides, where this becomes what? A square. A square equal to 5c square, or a square equal to 5c whole square. Okay, 5c whole square means the square is applicable for 5 and the square is also applicable for c, right? So then this becomes what? 5 square into c square, 5 square. Okay, let me write over here. A square equal to 5 square. 5 square means 25. C square as it is c square. Okay. Now here I have got a square, right? Here I have got a square. Now when you look over here, where a square equal to 5b square, right? We know here where we can see over here where a square equal to 5b square. We got it, where a square equal to 5b square. Instead of a square, what do? I will try to replace 5b square over here. Okay, instead of a square, I would like to write 5b square. So what you do? You write 5b square equal to 25c square. Clear? 5 ones are 5, 5 5s are 25. Okay, 5 5s are 25, right? Now here you go like b square equal to 5c square. B square equal to 5c square. Here comes the thing, where here I have said what? Where a square equal to 5b square means a square equal to 5b square means here 5 and b square are the common, 5 and b square are the factors of a square. Here b square equal to 5c square, where 5 and c square are the factors for b square, right? 5 and c square are the factors for b square. So therefore what do I do? What do I say? Where 5 divides, I can say 5 divides b square. 5 divides b square. If 5 divides b square, what happens? 5 also divides b, right? So 5 divides b. Clear? This will be the other statement or the second statement. Okay. So here we have got one statement where 5 divides a. Here we got another statement where 5 divides b. So guys, here a and b, we have said what? Where a and b are co-primes, right? A and b are co-primes. There we will be having only one factor as a common factor, but here a and b are co-primes, but we are getting what? 5 divides a, we got 5 divides b. So we have proved it. What do we do? Other than one factor, we are getting more factors. Means 5 is another factor that we got, right? So we have got another factor also. So therefore this is a contradiction. Our assumption is false, that what we have assumed root 5 is a rational number. So therefore our assumption is false. You will be having two statements to write in the conclusion point, where therefore root 5 is an irrational number. And therefore our assumption is false. Assumption our assumption is false. Clear? This is the thing, guys. Note it down. Now let me go for the next one, the fifth one. 3 plus 2 root 5. Clear? Hope you got it. Now let's go for the next one, the fifth one. 3 plus 2 root 5. So now here, where we got 3 plus 2 root 5. 3 plus 2 root 5, we should prove this an irrational number. Then what you do to prove 3 plus 2 root 5 as an irrational number, what you do, firstly consider this our given this number as a rational number. Okay, so consider 3 plus 2 root 5 as a rational number. So then let us write down, let 3 plus 2 root 5 is a rational number. Is a rational number. Okay, 3 plus 2 root 5 is a rational number. Then if 3 plus 2 root 5 is a rational number, then what you do, rational number is always in the form of p by q. So instead of p by q, I would like to assume a by b. Okay, I will be taking a by b form. So 3 plus 2 root 5 equal to a by b. I have considered a by b because I assumed that 3 plus 2 root 5 is a rational number, where rational number is always in the form of p by q form. Q is not equal to 0. P and q are integers. Now 3 plus 2 root 5 equals to a by b, where it is in the form of a by where this is equal to a by b. Now what happens, what you do, you transpose this plus 3 to the other side. Okay, ask plus 3 to go to the other side. So let us send this plus 3 to the other side. This becomes minus 3, means here you have positive sign. If I transpose this becomes negative sign, as we know, we are learning from very early age. So where here 2 root 5 equal to a by b minus root 3, minus 3, sorry, a by b minus 3. Okay, now this becomes a 2 root 5 equal to a by b minus 3. So guys, here you take what, LCM. Okay, so b will be the LCM and numerator by denominator, this becomes a, minus LCM and numerator by denominator, this becomes 3b. Clear? As it is, you go and write like 2 root 5 equal to a square minus 3b by b. Now what you do, transpose this 2 to the other side. Here 2 is getting multiplied. So if I ask 2 to go to the other side, what this 2 would become? This becomes division. Okay, divided. So where here you have root 5, where root 5 equal to a minus 3b by 2b. Okay, this becomes 2b. Clear? This becomes 2b. So root 5 equal to a minus 3b by 2b. We know root 5 is an irrational number, right? We know that root 5 is an irrational number. Okay, as we have here, we have proved, right? We have proved root 5 is a rational number. But you know, if we won't get like this prove method, but you go like we know that root 5 is a rational number. Okay, where so here this a 3b or 2, here a minus 3b by 2b is a rational number. Right, so where a and b are integers, 3 and 2 are integers, they are numbers, they have values, they are integers. Where root 5 is an irrational number, so where root 5, we know root 5 is an irrational number. Okay, and this where a minus 3b by 2b is a rational number, where irrational number cannot be a rational number, right? So therefore irrational number cannot be a rational number, so therefore our assumption is false. Let us write down here, therefore our assumption is false. 3 plus 2 root 5 is an irrational number, therefore our assumption is false. This is a contradiction that we got. So you can write more points on it, like you can write, oh, this is a contradiction where 3 plus 2 root 5 is an irrational number. So here where root 5 is an irrational number, where this is a rational number, where there's both, where irrational number cannot be rational number, where irrational number is not equal to a rational number. So therefore this is a contradiction. We won't get, okay, where this is an irrational number, as we can write over here. Okay, clear? Again, let's start with the second one. Prove that root p plus root q is irrational where p q are primes. Where prove that root p plus root q is an irrational where P comma Q are primes. So guys, here they have given root P plus root Q is an irrational number, right? So they asked to prove that root P plus root Q is an irrational number where P comma Q are prime numbers, where prime numbers are the numbers where they will be only having one factor. There are no factors other than 1. Okay, where prime numbers they will be having no factors. There are no factors other than 1. 1 is the only factor that they will be having. Okay, so few numbers will be having. So here P comma Q are prime numbers they have given. Now what do you do guys? As we know the basic rule where the sum of any two irrational number is always an irrational number. Means here let us assume like where root P plus root Q. We know that root P is an irrational number and root Q is an irrational number. So the outcome which is there, okay, the result which is there, it will be an irrational number, right? It will be an irrational number. Or if you go, okay, let's take other example like here, okay, root 2. Root 2 is an irrational number, we know. Alright, are you getting it guys? Where root 2 is an irrational number. Root 2 plus root 3 is also an irrational number. Where root 2 plus root 3 gives root 5. Where root 5 is an irrational number that we got, right? Root 5 is an irrational number that we got. So therefore I can say that the sum of any two irrational number is always an irrational number. So here they have given what? Root P plus root Q. So root P plus root Q, if you add this both, where root P plus root Q is an irrational number. So that's why if we add this both numbers, okay, that's why if we add root P plus root Q, we are getting an irrational number. So therefore these numbers which are there, okay, the numbers that we are adding will also become an irrational number, right? So this is what we can say, okay. So therefore let us again conclude those same points. Therefore root P plus root Q. Therefore root P plus root Q is an irrational number. Is an irrational number. Clear? Therefore root P plus root Q is an irrational number. Clear? Thank you.